Well, our equals sign is on vacation and its place is being taken by an inequality, in this case a greater than symbol. If you're going to solve one of these algebraically, in most ways you treat it the same way that you would in equals, with one major exception, which we will get to shortly. So, first of all, I want to distribute this -2 through here. We want to get rid of the brackets as quickly as possible. So, 4, -2 times 3 is -6, -2 times x is -2x, and that's greater than 12. 4 minus 6 is -2. Alright, so that's an improvement. Now, we want to isolate x, just like if this were an equation, we want it to be x equals. Here, we're going to end up with x is greater than, or some variation on that. So, we can get rid of the -2 here. If we add 2 on each side, that gets us to -2x is greater than 14. And now, last thing we do to isolate x, we divide both sides by -2. -2x divided by -2 leaves x. 14 divided by -2 leaves -7. And what goes here? Do you remember? This is the one thing that's different when you're doing an inequality. If you multiply or divide by a negative number on both sides, this inequality turns to flip the other way. So instead of being a greater than, this now becomes a less than. X is smaller than, less than or equal, just less than -7. That's our algebraic solution. So you can add, you can subtract, you can expand brackets, you can do all of that stuff. The only difference is when you multiply, or in this case when you divide by a negative number like this -2, the inequality turns to face the opposite direction. Check the solution using a test case. A test case means, because we're talking about a range of numbers here, anything lower than -7, there's all kinds of different ways you could test it. I'll use -10. We'll say x is -10, and we'll see if that works for this inequality. 4 minus 2 times 3 plus -10 is greater than 12, I think, I hope. Let's find out. We get 4 minus 2, 3 plus -10 is -7. 2 times -7 is plus 14 is greater than 12. 4 plus 14 makes 18 is greater than 12. Is that true? Yeah. Yes, it is, so the test case worked. If you want to do it with -8 or -7.1 or any number that's lower than -7, you should get a true statement like I did here. And another way you can check these, this generally isn't necessary, but I'll show you. If you take a number that isn't lower than -7, let's say if x equals 0, this should fail. Right? This expression is saying this inequality is fine as long as x is lower than -7. So I'm taking 0, which isn't lower than -7. Let's see what happens. We get 4 minus 2, 3 plus 0, greater than 12. 4 minus 2 times 3 plus 0 is just 3. That's 4 minus 6 is greater than 12, which comes out to -2 is greater than 12. No, this is false, and it's supposed to be. I picked a number that intentionally that would not work. So you can do test cases that you think are going to work, that obey this, or you can totally ignore this and take a value that shouldn't work and confirm that it fails. Those are test cases. If you graph the solution on a number line, let's see, we have 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. This solution says x can be lower than -7. It can't be exactly -7, so I'm not going to draw a solid dot here. I'm going to leave an open circle, and then we're supposed to be lower than minus 7, so I'm going to draw an arrow that goes down into the lower numbers to the left. This is how you write x is less than negative 7. If it were less than or equal to, then this would be a solid black dot. If it were greater than, our line would be extending to the right instead of to the left. We'd be going up into the higher numbers. But this is start at minus 7, don't touch minus 7 because we don't have our equals, and then do all the numbers lower than minus 7 so our arrow points down into the negatives.